Activity what we are doing is we should have a board that I will show you. Okay, if possible I will bring that board and show you. First suppose you have a board here, and on this board you are just fixing a sheet, a chart paper or a white sheet. Okay, and we are just fixing here pins so that it doesn't move, the sheet is not moving. Okay, so you have a board here, inside that you have a sheet, chart paper or a white sheet. Now what we are doing is we are just randomly attaching certain points, in the sense pins, small pins we are attaching. Okay, and then what we will do is we need either wires, or you can just use threads also. Okay, first what we will do, we will just take 3, so like this we will just attach pins at a time. We are just joining the 2 pins using the threads. Okay, thread or wire, whatever we are using. So like this 3 parallel things we are just joining. So whatever are giving you parallel, those we are joining. Then again we are just taking 3 perpendicular lines like this. Okay, so you have 3 parallel lines, 3 perpendicular lines. We are just taking them as L1, L2, L3, L4, L5, L6. Okay, so these are the things which we have. Now again what we are doing is perpendicular to L4, L5 and L6. Now when you take the other thing, that is L2, that is also giving you the same result, that is L2 is perpendicular to L4, L2 is perpendicular to L5 and L2 is perpendicular to L6. Again L3 perpendicular to L4, L3 perpendicular to L5 and L3 perpendicular to L6. All these conditions you will get from this one. Okay. Now when I say L1 is perpendicular to L4, can I say L4 is perpendicular to L1? L1 perpendicular to L4 gives you L4 also perpendicular to L1. That means you can say the meaning of this is if L1, L4 belongs to R. What R is? If you have perpendicular lines, they will be having a relation in between them. So it belongs to, this set belongs to R. If I am taking L1 is perpendicular to L4, L1, L4 belongs to R. And that is giving you that L4, L1 is also belonging to R. And what is the definition of this? That is symmetricity. So you can say that symmetricity is satisfied here. You choose any pair, the opposite is also having the same thing, right? That is also belonging to R. So symmetricity is satisfied there. Okay, now going for the second one. So that's what the activity says, that this relation is symmetric. If you take 2 perpendicular lines, then the other way also they will be perpendicular to each other. So in that condition you can see that all of them have that pair. Okay, if one pair you are taking to be perpendicular, the other pair, the opposite pair will also give you the same thing. Now for reflexivity, if I take one line L1, is L1 perpendicular to itself? Any line is perpendicular to itself? No, right? So if I am taking, and for reflexivity we have L1, L1 belongs to R for all, right? L1, L1 should belong to R for all N1 in whatever set you are taking. So in the set of lines, if you are taking a particular ordered pair L1, L1, it should belong to R for all the things, right? For all them. So if you are taking L1 or L2, anything, the pair will not belong to R, right? Why it is not belonging to R? Because L1, a line is not perpendicular to itself. So L1 is not perpendicular to L1, therefore L1, L1 does not belong to R. That means it is not reflexive, right? It is not reflexive. What is not reflexive? R is not reflexive. The relation which is given, that is L perpendicular to M, that relation is not reflexive. Now moving on to the third one, that is transitivity. For transitivity, what would we need to do? We have to take 2 things and then the third condition should also be satisfied. That means if I am taking L1 is perpendicular to a pair which is having its perpendicularity with it. Okay, if I am taking L1 and L4, they are perpendicular. So I will get L1, L4 belongs to R implies L1 is perpendicular to R, right? Or you can say L1 is perpendicular to L1 is perpendicular to L4, so these pair belongs to R. belongs to R. Now if I am taking L4 and this, we have already seen that L2 is also perpendicular to L4. So if I am taking the continuous part of this, L4, L2 also belongs to R. Why? Because L4 and L2 and L2 are also perpendicular to each other, right? So you are getting L1, L4 belongs to R, L4, L2 also belongs to R, because L1 is perpendicular to L4 and L4 is perpendicular to L2. But from these two conditions, can you say that L1 is perpendicular to L2? For your transitivity, you have like this: L1 perpendicular to L4 and L4 perpendicular to L2. It should imply that L1 is perpendicular to L2. Is it possible? The two have the relation like they are parallel. They are parallel, right? So this is not possible. So you can say that the relation R is not transitive. This is what we are showing in the activity. Okay, this relation of all Lm, where L is perpendicular to M, is symmetric but neither reflexive nor transitive.